So, in this class we shall consider some problems based on the numerical methods that we have developed to solve equations of the form f of x is equal to 0. So, let us consider the following problem. We are asked to derive the iteration method of the form x n plus 1 equal to x n by 2 into 3 minus n x n square to obtain square root of the reciprocal of a number n, and use this method to compute 1 by square root of 1000 correct to 6 decimal accuracy. So, what is the problem? We are required to obtain the square root of reciprocal of a number n. So, find x such that x is 1 by root n, or x square is equal to 1 by n, or n is equal to 1 by x square. So, let us solve the following problem. F of x is equal to 0, where f of x is given by n minus 1 by x square. So, let us apply Newton-Raphson method and solve this problem. So, what is Newton-Raphson method? It gives you x n plus 1 equal to x n minus f of x n by f dashed of x n. Why did I choose Newton-Raphson method? For a simple reason that when I look at the answer that is given in the problem, it is like x n plus 1 is equal to something. So, let us try to apply Newton-Raphson method and see whether our computations finally yield us the method as this. So, it will be x n minus, what is f of x n? It is n minus 1 by x n square divided by, I require f dashed of x n. So, let us compute f dashed of x. So, that will give you 2 divided by x cubed. When we simplify this, we end up with 2 x n by x n cubed minus n plus 1 by x n square multiplied by x n cubed by 2. So, this gives you 2 by x n square minus n plus 1 by x n square into x n cubed by 2. So, I have 3 by x n square minus n multiplied by x n cubed by 2, and that simplifies to x n by 2 into 3 minus n x n cubed, and what is it? That is x n plus 1. We observe that this is essentially what appears in the given problem. So, what is it that we have developed? We have developed an iteration method given by x n plus 1 equal to x n by 2 into 3 minus n x n cubed for finding the square root of the reciprocal of a number n, which is a positive number, and we are asked to compute 1 by root of 1000 correct to 6 decimal accuracy. We require an initial approximation x naught. So, let us try to find out an x naught, so that when I know x naught, I can generate the iterates x 2, x 3, etc., and stop the computation when I have achieved the desired degree of accuracy. So, we know that we require root of 1000. So, let me start with square root of 900 is 30 and square root of 1600 is going to be 40, and so root of 1000 will lie between 30 and 40, and therefore, I require 1 by square root of 1000. So, it will lie between 1 by root of 1600 and 1 by root of 900, namely will lie between 1 by 40 and 1 by 30, or it will lie between 0.025 and 0.033. So, I can take my x naught to be a value which is less than 0.033. So, let me take it to be 0.03. So, once I know x naught, I make use of this iteration scheme and find what x1 is and then x2 is and so on. And the problem says determine this 1 by root of 1000 correct to 6 decimal accuracy, and I leave the rest of the computations for you to complete. Starting from x naught, you work out the details and then find out what is 1 by square root of 1000 correct to 6 decimal accuracy. Let us now consider the following problem. We are asked to show that an initial approximation x naught for finding the reciprocal of a number n, where n is a positive integer, by Newton-Raphson method must satisfy the condition that x naught should lie between 0 and 2 by n for convergence. Any other value of initial approximation x naught which lies outside this interval will make the sequence of iterates to diverge. The initial approximation for finding the reciprocal of a positive integer n must satisfy the condition that x naught must lie between 0 and 2 by n. This is what we are asked to show. So, what is it that we want to solve? We want to find that x which is the reciprocal of the positive integer n, or n is 1 by x. So, we need to solve the equation f of x is n minus 1 by x. So, we would like to apply Newton-Raphson method, and it is also given in the problem solve by Newton-Raphson method. So, I compute f dash of x, and Newton-Raphson method is xn plus 1 equal to xn minus f of xn by f dash of xn. So, substitute in the method. So, we get xn plus 1 is xn minus f of xn by f dash of xn, and if you simplify, you end up with 2xn minus n xn square. So, the iteration method for solving f of x equal to 0 is xn plus 1 equal to 2xn minus n xn square. So, we would like to now show that this iteration method converges provided we take the initial approximation x naught to lie in the interval 0 to 2 by n. So, let us try to work out the details. So, this iteration method is of the form x is equal to g of x. This we have already seen. Newton-Raphson method belongs to the class of fixed point iteration method, where the right hand side x minus f of x by f dash of x is g of x. So, I take g of x to be 2x minus nx square and write down the error at the n plus 1 step. What is error at the n plus 1 step? It is xn plus 1 minus p. What is p? It is the root to which the sequence of iterates converge to. What is it that I want? I want to find my root which is x, and that is 1 by n. So, here p is 1 by n. So, xn plus 1 minus p gives me en plus 1 with p as 1 by n. So, I n plus 1 because that is 2xn minus nxn square minus. So, I write 2xn as xn plus xn and take one of them here as xn minus 1 by n and the other here. So, I have a xn minus n xn square. So, we have xn minus 1 by n plus I can take out the factor xn. So, xn into 1 minus n xn and write this term as n xn into 1 by n minus xn. So, from these two terms I can remove the factor xn minus 1 by n, and then other factor will be 1 minus n xn. But I know that this is the error at the nth step. So, this is E n multiplied by 1 minus n x n. So, what is it that we have shown? We have shown E n plus 1 is E n into 1 minus n times x n. So, we make use of this and write down what is the error at the first step in absolute value. So, E1 mod E1 will be modulus of 1 minus n x naught into mod E naught. What will be mod E2? Mod E2 is mod 1 minus n x naught into mod E1, that is mod 1 minus n x naught into mod E naught. So, we can write down mod E2 to be mod 1 minus n x naught the whole square into mod E naught. So, we continue to apply this inductively, and finally, we get mod E n to be modulus of 1 minus n x naught to the power of n into mod E naught. I want the error at the end step to go to 0. When the error approaches 0, what is this E n? E n is x n minus p. So, as n tends to infinity, when E n goes to 0, x n will converge to p, namely the sequence of iterates will converge to a root of the equation. So, I want this E n to go to 0. When can that happen? When this quantity within absolute value is less than 1. So, a quantity less than 1 is raised to the power of n. So, as n tends to infinity, this will go to 0. So, the error at the end step will go to 0. So, that requires that mod 1 minus n x naught less than 1. What does that mean? It means 1 minus n x naught lies between minus 1 and plus 1. So, when I add 1 to this inequality, then I end up with 0 less than x naught less than 2 by n, which clearly tells us that the initial approximation x naught lies between 0 and 2 by n, and if this happens, then the sequence of iterates converge to a root of the equation, namely the value that you get will give you the reciprocal of the given positive integer. Let us now consider this problem of solving the given equation by Newton-Raphson method, taking convergence tolerance epsilon as 5 into 10 to the minus 3. So, given f of x is equal to 0, we determine an interval within which a root lies, so that our initial approximation will lie within this interval. And if we start with such an initial approximation and generate the successive iterates to determine a solution of this problem. So, we observe that f of 1 is less than 0 and f of 5 is greater than 0. So, a root lies in the interval 1 to 5. So, we shall start with an initial approximation anywhere in this interval. So, let us take it to be say 5 and then apply Newton-Raphson method. X n plus 1 is x n minus f of x n by f dash of x n. So, knowing x naught equal to 5, we obtain the right hand side and that will give you x 1. So, that is 5 minus f of 5 by f dash of 5, and that turns out to be this. With this as x 1, we compute x 2 and we check whether the difference between the successive iterates satisfy the required accuracy. No. So, we continue to compute x 3 with x 2 used on the right hand side for x n. X 3 turns out to be this. So, we observe that we have desired degree of accuracy when we compare the solutions at the third step and the second step, and we stop our computations and conclude that x is equal to this is a root of the given equation obtained using Newton-Raphson method, and it is correct to the desired degree of accuracy. Let us now consider the following problem. We are asked to determine constants p, q, r which appear in this iteration method, xn plus 1 equal to p xn plus q a by xn square plus r a square by xn power 5 for determining cube root of a number, say a, such that the order of convergence of this iterative method is as high as possible. What does that mean? We have already discussed. If a fixed point iteration method is given as x is equal to g of x, with g as a continuous function in the interval a b and has continuous derivatives up to order alpha in the open interval a b, and if p is a fixed point, so that g of p is p and g dash, g double dash etc. up to alpha minus 1th order derivative of g at p is 0 and the alpha order derivative of g is different from 0, then the order of convergence of this fixed point iteration is alpha. So, we observe that we have a fixed point iteration of the form x is equal to g of x. For solving the equation x is equal to a to the power of 1 by 3, namely for solving or determining a cube root of a number a. So, let us assume that psi is a fixed point of x is equal to g of x. What is x? X is a power 1 by 3 and that is psi. So, x cubed will be psi cubed and that is a. So, we will make use of that because psi is a fixed point for x is equal to g of x. What is g of x? It is the right hand side, p x plus q a by x square plus r a square by x to the power of 5. So, what are the conditions? We should now see whether g of psi is psi. What happens to g dashed of psi, g double dashed of psi and so on. How many unknowns which we have? There are 3 unknowns p, q, r. So, we require 3 conditions to determine these unknowns. So, we make use of the conditions as follows, namely g of psi must be equal to psi, g dashed at psi must be 0 and g double dashed of psi must be equal to 0. So, I must determine p, q, r which appear in g in such a way that this g has the following properties, namely g of psi is psi, g dashed of psi is 0 and g double dashed of psi equal to 0. So, I will have 3 conditions to determine the 3 constants p, q, r. Let us do that and then continue our discussion. So, take g of x to be given by the right hand side. Then see what happens if you impose the condition that g of psi equal to psi. So, g of psi is p into psi plus q a by psi square plus r a square by psi power 5. But what is psi? It is a power 1 by 3. So, use that fact, that will give you a power 1 by 3 into p plus q plus r, that is g of psi. But that must be equal to psi which is a power 1 by 3. So, this immediately gives you the first equation satisfied by p q r, namely p plus q plus r must be equal to 1. Let us now compute g dashed of x and evaluate it at x is equal to psi. So, g dashed of x will be p then minus 2 q a by x cubed minus 5 r a square by x to the power of 6. Evaluate this at psi. So, g dashed of psi equal to 0 will give you p minus 2 q a by psi cubed minus 5 r a square by psi power 6 and that must be 0. So, that immediately gives you, making use of the fact that psi cubed is a. So, we get p minus 2q minus 5r is 0, that is the second equation. Then we require g double dashed at psi to be equal to 0. So, compute g double dashed of x, evaluate it at psi and equate it to 0, that gives you q plus phi r equal to 0. So, we now have 3 equations from the 3 conditions that g of psi must be psi, g dash of psi must be 0, g double dash of psi should also be equal to 0. So, we solve for p, q and r. So, this gives you q to be minus 5r. Use that information here. P will be 1 minus q minus r, or use this information in p plus q plus r is equal to 1. That will give you p equal to 1 minus q minus r. So, p will be 4r plus 1. So, use p as 4r plus 1 and q as minus 5r in this second equation, p minus 2q minus 5r equal to 0. So, that gives you r to be minus 1 by 9, and hence evaluate q, that is 5 by 9, and finally you have p given by 4r plus 1. So, p is equal to 4r plus 1, that is 5 by 9. So, you have determined p, q, r by imposing the three conditions, namely g of x will therefore be 5 by 9 into x plus q is 5 by 9 into a by x square. Then r is minus 1 by 9 into a square by x to the power of 5. So, you have determined p, q, r such that you have now an iterative method for obtaining the cube root of a number a. What do we want? We want the order of convergence of this method to be as high as possible. Whatever that we have done shows that it has at least third order convergence, right? Why? Because g dash of psi is 0, g double dash of psi is 0. We still have not calculated what is g triple dash of psi is. So, at this stage we can make a statement that this iterative method has at least third order convergence. So, we should now find out whether it has third order convergence or it has convergence of higher order. So, in order to do that, we compute the third derivative of g at psi. So, let us find out g triple dash of x. So, it turns out to be this, and evaluate it at psi. That comes in terms of q and r. We have evaluated the values of q, r, etc. So, substitute for q and r. We observe that it is minus 24 by psi square into 5 by 9 plus 210 by psi square into 1 by 9, which is different from 0. So, what is it that we have shown? We have an iterative method, which is a fixed point iteration method of the form x is equal to g of x, which has the following property, namely g of psi is psi, g dash of psi is 0, g double dash of psi is 0, but g triple dash of psi is different from 0, and therefore, the order of convergence of this method is 3, that is the highest order possible, and we conclude that the method for computing cube root of a number a given by this has cubic convergence. Let us now work out the following problem. Here we are required to compute the positive root of the equation x is equal to a minus b x square, where a and b are positive. Using an iterative method given by xn plus 1 equal to a minus b xn square. We are asked to find out the condition on the convergence of this iterative method. So, let us look at this method. We observe that it is of the form x is equal to g of x, with g of x given by a minus b x square. And we have to solve g of x is equal to x, or we have to solve this quadratic equation b x square plus x minus a equal to 0, which gives you x is equal to minus 1 plus or minus root of 1 plus 4ab by 2b. We want this root to be a positive root. So, if I call that root as alpha, then alpha must be minus 1 plus root of 1 plus 4ab by 2b, and since this has to be a positive root, this minus 1 plus root of 1 plus 4ab by 2b must be positive. Since b is positive, this implies that root of 1 plus 4ab must be greater than 1, or 4ab must be greater than 0, which is true because a and b are given to be positive. So, now let us find out the condition for convergence. We have already seen this condition in our results, which we have shown earlier. If you are given a method which is x is equal to g of x, for convergence, modulus of g dashed of x must be less than 1 at this root, and here the root is alpha. So, we must have for convergence modulus of g dashed of alpha to be less than 1. So, we compute g dashed of x from here, which is minus 2bx. So, at x is equal to alpha, we have mod minus 2b alpha to be less than 1. So, this implies modulus of minus 2b into, we already have shown that the positive root is given by minus 1 plus root of 1 plus 4ab by 2b. So, we substitute for alpha as that, and we must have absolute value of this to be less than 1 for convergence. So, this gives you minus 1 plus root of 1 plus 4ab must be less than 1 in absolute value, which implies minus 1 less than minus 1 plus root of 1 plus 4ab, and that must be less than 1. So, adding 1 throughout this inequality gives you 0 less than root of 1 plus 4ab less than 2, which shows that 4ab must be less than 3, and therefore, a and b are such that the product ab must be less than 3 by 4. So, if you are given an equation of the form x is equal to a minus bx square, where a and b are positive, satisfying the condition that ab is less than 3 by 4, then the iterative method given by xn plus 1 equal to a minus bxn square, which is a fixed point iteration method, is guaranteed to converge to a positive root of the equation given by alpha is equal to minus 1 plus root of 1 plus 4ab by 2b. That is what the problem illustrates. We stop here and then continue our discussions in the next class.